It's now time to start speaking about DAX optimization example. How many of you already know DAX? Everybody. Cool. That was the only question. How many of you use Power BI? Analysis services? Yeah. A lot of people using Power BI, somebody using analysis services. OK. Please silence your phones. And before I ask you to silence the phones, it's good to check that if I silence mine, which I did. OK. And explore everything PaaS has to offer. I guess you have seen these slides enough time during these days, so I'm not going to spend time here, and I'm not going to spend too much time explaining who I am, not because I'm famous, but because I guess you are not interested in understanding anything about my private life. I'm Alberto Ferrari. I work at SQLBI.com with Marco Russo. We founded SQLBI.com a few years ago. In the last few years, we basically work on analysis services tabular. It's not that we don't like multidimensional, but I mean, you need to specialize on something, and we decided to specialize more on tabular and on the DAX language. For this reason, we wrote a lot of books, courses, and stuff that you can look at on the website. If you go to SQLBI.com, you will discover. How many of you know SQLBI.com? So all this chat is totally useless. We can move further. What I want to talk about today is how to optimize DAX code. So it typically all starts with somebody, a colleague, the CIO, somebody who comes to you and say, hey, I have this report, and it's not fast enough. It looks slow. Would you mind helping me in optimizing it? I'm pretty sure it will be very, very quick. This is when you start to have fear. You say, well, it might be. Even because, I mean, I guess all of you have seen, well, the keynote where they shown a lot of data with aggregations, and then Christian Wade showing how Power BI can query 1 trillion rows. And it was fast, 2-3 seconds to query 1 trillion rows. I have never seen in my entire life 1 trillion rows. I cannot even imagine 1 trillion rows. But for sure, what I see in the real world is something completely different than that. What I see is that a report with just a bunch of millions of rows can be very, very slow. If you write the DAX code the wrong way, if you don't understand how the engine works, if you just write it or are a newbie, or maybe you are experienced, but you just write your code and everything slows down. So I'm not here to teach you how to optimize trillions or billions of rows, because that's not a natural experience. The real world is made of a few million rows, and already at that size, DAX can be extremely slow. So we need to understand how to write it in the better way and how to optimize the code. Okay? By the way, how many of you have trillions of rows? So we need to talk, because I want to see 1 trillion rows. How many of you have billions of rows? Well, start to be more interesting. As I said, we are not going to talk about those kind of models. I deliver other sessions when we speak about large models. Now the focus is just DAX code and how to work and optimize. So what we will do is take a report, just a simple report that runs on a few millions of rows, and we learn, first of all, what are the tools that you need to use in order to understand where the performance issue is, how to measure it, how to control, how to check if everything is running fine or not. In the meantime, in the process of optimizing, we will do that step by step. And something that might make the session more entertaining is the fact that I really don't know what I will do in order to optimize the code, because the goal is doing everything, not together, but everything online. So I will not just copy and paste formula. I want to write everything, so we learn it by doing. And in the meantime, we will learn what the formula engine and storage engine are, how to measure performance, how to detect where the bottleneck is, how to be able to reproduce the issue, so to measure something and then reproduce it multiple times in order to fix the problem. And as I said, I don't want to show you how to move a query from 10 minutes to 100 milliseconds, so they say, whoa, but then you don't bring back home anything. I want to simulate something which is very real world. After this introduction, we will basically not use the slides apart from some recap, and we will start doing everything together. So that guy came to us and said, hey, I have this report, and it's not very fast. Power BI by itself is not very fast in opening, but you see that just opening the report takes some time. It's computing. This is still computing. It finished doing that, and it's still computing open orders, amount USD and amount euro. After something like 20 seconds, we have the report here. And this is very, very different from the experience you would like to have with Power BI. With Power BI, you want to do click, 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 and all the numbers come out immediately. If this doesn't happen, it's disturbing. Where do we start? Well, typically, you start by looking at the model. There are just a bunch of tables here. There is nothing really complex. We have a fact table containing orders, then a date dimension, exchange rate, and currency, because this guy do currency exchange, and then a customer table. It's a pure star schema, nothing strange, with a many-to-many here in a hidden table. So the data model by itself is not strange. There are no bidirectional filters. Have you seen the session of this morning on Marco? So you know bidirectional filter is bad. If you use them, you will go to hell, as easy as it is. Nevertheless, so we don't have bidirectional filters here. We only have one fact table, and it only contains 1.6 million rows. It's very far. It's 3 orders of magnitude less than 1 billion, 6 orders of magnitude less than 1 trillion, yet the report is low. So where do we start? You can start from a lot of different tests. But what I typically see people do is, well, if I need to understand or if I need to start optimizing the code, well, I Google, I search, that's not the right place, we Bing, or we search, well, you Bing, you don't find, then you Google. Anyway, you search for the solution somewhere. And this is what we all do. But what I'm here, and what I think is the most relevant message that you need to learn from this session is that Googling is not an option. It's not the right thing to do. Imagine that you have moved the Googling stuff in another scenario. So imagine that you have some pain on your arm. It hurts. So you wake up, the arm has a pain, and you go to the doctor. Say, hey, doctor, I have pain in my arm. What would you think if you start Googling? Pain, arm, remove. It's scary. They say, hey, I found a blog post. Sweetheart 95 says, if you cut off the arm, then the pain will go away. You don't want to be there, especially if you have a headache. That is much worse. So what you need to do is just follow what a typical doctor would do. The doctor looks at you, looks at your arm, start making tests, examinations, understand exactly what is happening, and only when you know where the problem is, then you can do something and correct it. So in order to understand where the problem is here, we have a lot of different entities here, because we have one chart, one matrix, 2 matrix, then a column chart, a complex diagram, and a slicer. All of these will run queries against your engine. And which one is the slowest? Where should I start working? I see a lot of people spending tons of time optimizing a measure which is not responsible of the slowness of the entire query. So that's a waste of time. You are just spending days to optimize something that does not need to be optimized. So first of everything, you need to understand the time required for all of this part of the report. And unfortunately, no matter how much you search, Microsoft does not provide you any tool to query a Power BI report. to query performance of Power BI report or to analyze the performances of a report. With analysis services, at least we have the profiler. Hard to say it's a beautiful tool, but at least it gets its job done. So you can use it to measure the performance. With Power BI, there's nothing that you can do unless you know, as I guess you already know, that Power BI is basically analysis services running side by side with Power BI. It's a different process, but it's running specifically for Power BI. Nevertheless, just connecting to it moves you in the unsupported area. So Microsoft does not support anything of what we are going to do from now on. But that said, we need to do it, and so we do it. So if you want to analyze your report, the first thing that you need to do is search for a tool that helps you. Well, this is not useful. The useful part is DAX Studio. How many of you already know DAX Studio? Not so many. I was hoping many, many more. DAX Studio is an open source tool that Darren Gospel and Marco wrote, and then other people contributed to writing. It's basically the answer to all the missing tool coming from Microsoft. Microsoft does not give us tool in order to write DAX code in an efficient way or to measure performance or to understand where the problem is. If you want something done, you do it by yourself, and this is exactly what we have done. We created this tool. It's completely free. So you simply go there, download, install it, and your life with DAX will really, really change. Because it's a tool that is able to run DAX queries, and it works with Power BI, Power Pivot, Analysis Services, Tabular, Azure Analysis Services, any kind of tool, you name it, and it will work as long as it runs DAX. And it provides you a lot of information about the engine. The next step will be understanding the information. So only having data is totally useless unless you know the content of this data. So we can simply open DAX Studio. As I said, right now, Analysis Services is running, and it's answering queries which are here. DAX Studio lets you connect just a quick information from the bottom. Can you read that side or that side? This is much better. OK, so if you don't read something, just cry zoom, and I will do that, because I typically forget it. DAX Studio is able to connect to Power Pivot if it's open, and if it starts from Power Pivot, any Power BI file or a tabular server. Right now, we want to connect to a Power BI, and the only file we have open is DAX optimization example. So we can connect, and just very, very quickly, what DAX Studio offers is the list of all the table with all the measures and everything here. So you have all the metadata information here, and a lot of interesting buttons. We are not going to cover all of them, but we want to see them one by one. Now that we are connected with analysis services, so we are basically connected with Power BI, DAX Studio gives you a button here, All Queries. If you click on that button, something amazing happens, meaning that DAX Studio connects to analysis services, Power BI in such a case, and it will simply grab all the queries which are executed by Power BI. So you open the report, and all the information about the query, the time needed to execute, and all the data will be traced by DAX Studio. Unfortunately, even if we click on All Queries, and it says Query Trace started, so we are happy and ready to go, if you go to another report and then go back, then we go here and look at all the queries, you see that we see only one query. We are not going to analyze this in detail, but the query you are seeing here is only one query, and it is the query that executed this report. And if I go back and forth between the pages multiple times, look at there. The query is still only one. We have only one query that took 124 milliseconds. Why that? Power Query is smart enough that if you run the same query multiple times, it will simply cache it. There's no point in running the query multiple times. And this is extremely useful because when you change a query, so you go here and say, well, I don't want a table, I want a matrix, or I want to change it back to a matrix, it's very, very fast, even if this query by itself is a very slow one. And it's fast because it doesn't do anything. So what can I do if I want to monitor a report and understand what is happening? What I can do is change the query. If I click on clerical, so I change the occupation, you see that it takes some time to refresh. But clicking on different items on the slicer basically changes somewhat the query. So you no longer have the original report. And besides, at some point, you will finish all these filters, and you are in trouble because you need to close and reopen and start again. So the first suggestion that I can give you is if you need to do any kind of performance analysis, just add an empty page to your file and then save it. What's the purpose of doing it? When I will open the Power BI report again, it will not do anything. It will simply open an empty page and start sleeping. So let me close here Power BI Desktop. Now I reopen DAX optimization example. The empty page will be the page containing all the information. So the engine will not do anything. Now I have all the time that I need to open DAX Studio, connect to Power BI Desktop, run the trace for all the queries, and my environment is set. Now I'm tracing all the queries, and I can go to the report that I'm interested in. It's taking time, and in the meantime, you see under all queries that all the queries executed are here. 1, 2, 3, 4. There should be 5 queries if I don't remember bad. Yeah, 5 queries. And for each query, you have the text of a query. We are going there in a few minutes. The duration, start time, the type, all this information is basically useless, but mainly we have the duration. So how long it took to execute the query.
What if you wouldn't refresh, give them the refresh all?
I always need to repeat the question for the recording. What if you do a refresh all? If you do a refresh all, it will reload all the data from the server, so it's going to take a while to do that. And the important thing here is that we are not going to use Power BI to do any kind of performance analysis. If you just click and look at the time needed to execute a query, you are not getting real numbers. You only have a feeling. Yeah, it's a bit faster, but you don't really have numbers that guarantees you that the query will run better again. If instead you run DAX Studio, you will be able to trace all the queries. And once you have a query, you can run it as many times as you want and measure in a very precise way the time that is needed to execute it. OK? So now we start to measure something. And what we discover is that, first of all, we need to fight with the cache. Right now, we are just fighting with the Power BI cache. Later, we will need to fight with the DAX cache. But when you measure performance, you want to avoid the cache at all. Because if you have the cache, all the measures that you take are basically the wrong one. And we created an empty page in Power BI that helps us in avoiding, in having the time needed to connect to the server and be able to do our operation. And most important, if we look at the different queries, we are able now to enumerate the time and look at the content. How do you know what the query is doing? Well, you simply double-click on the query, and this shows you the content of the query. That is, an evaluate the top 101 values of customer occupation, and what will it retrieve? We have this slicer that is showing the occupation, so it's pretty clear that that query is retrieving the data to fill the occupation. And you need to do the same process with all the queries. Let me show just another one. This is applying a filter for non-blank, so then it's taking the customer education and then the open orders. So it's retrieving customer education and open orders. And we have it here. You see, customer occupation, and then the measure shown is open orders. By doing this exercise, so by reading the content of the query and understanding what is the result, it takes some time, but you are able to measure the time needed to run all of the queries. Of course, the slicer is very fast. The second query there is a very quick one, the one that retrieves the sales amount in euro and does currency conversion. Then we have a query that retrieves the number of open orders sliced by occupation. Then we have another query that retrieves, again, the open orders by continent and year, and that's a bit slower. And the worst one is the one that retrieves the open order and the amount in euros, so it does currency conversion in the same chart, slicing it by date. So now we know that if we want to focus on something, then we need to focus on this one. We need to optimize first of all this, and we will be able to cut at least 13 seconds out of the report. And because the same measure is used in multiple places, it's likely that the benefit that we give to a query will propagate to all the other ones. Okay? So at least we know from where to start. Next step is looking at the query. We just double-click on it, and the query by itself is a simple one. It doesn't do a lot of operation. It evaluates the top 1,000 from a summarized column that does a group by year, month. It retrieves both the month and the month number because it will need to sort the month by month number, so it needs both columns. And then it returns 3 measures. Open orders, amount in USD, and amount in euro. Then these additional columns are needed only for sorting. What I typically do when I have a query like this, I start to remove stuff because I want it to be simpler. So we can remove all these, and we can also remove the order by. This is not going to change the speed of a query. Now it's just a summarized column of date, year, and next step is always formatting the query, so it's at least readable and you can look at the content. Now, this query is taking 13 seconds. We can check it again by simply running it. But if we want to measure the performance of the query, so if we want to understand how much time this query takes and what are the different timings, we need to disable all queries because the DAX Studio can either grab all the queries from analysis services or analyze in a deeper way one single query. This is what we want to do now. So we disable all queries, and we enable server timings and query plan. Let me just look at the output. When it says here, query trace started, you're happy. It means that it's able to start analyzing the plan. Let's run the query. Here it says query started, and here at the bottom it shows the time needed to execute it. It will be 7, 8, 9. We know it should take around 13 seconds to run. In reality, it took 11 seconds. There is some caching that we didn't clear, but that is not the biggest problem. Whenever you need to optimize code, you need, first of all, to measure it. Then you need to understand how much time it took, what are the different parts of the code that are executed. So it would be beautiful to have a query plan. Again, here we fight with tools which are missing, meaning that the engine fires a query plan. So this is, believe it or not, the query plan of the query that we have executed. It might be the case that you want to go through it, read, and understand what it is. At some point, you go faster because it's really, really strange. But it's 1281 rows containing text code that no human is able to read. So what is the purpose of the query plan? The sad truth is that we don't know. Nobody really knows how to read the content of a query plan. It's there. It's probably like some black magic art which is transmitted by voice only to your children. We were not lucky, so we have an idea of the content of the query plan, but you basically will never look at it, apart from the number of rows, which might be useful. Then there is the logical query plan. If the physical query plan is useless, the logical query plan is more useless. So it's basically a string that means nothing at all. What is instead very useful is this part of DAX Studio, which are the server timings. Server timings provide you the total execution time in milliseconds, so it's 11,073 milliseconds. And then it provides you this bar, which is very, very useful, but we will explain it slowly. The storage engine CPU, the formula engine CPU, and the storage engine execution time, plus the ratio between these two. We will go step by step in understanding what are all these pieces. But this is basically, for now, let's focus only on the total execution time. And the second important part is that it shows you here all the queries which are executed by the engine in order to answer your query. So it ran one query that retrieved 1.6 million rows, another query that retrieved 1.6 million rows, and the third query that retrieved 1.6 million rows. You can also look here at the code executed. This is not really SQL. It's called XMSQL, but it's very similar to SQL. So if you know how to read SQL, you will have no issue at all in reading XMSQL, because it's very simple to understand what it does. This is, for example, retrieving quantity, customer key, order number, amount, order date, and blah, blah, blah. So basically all the columns from the sales with a join on data, with a join on date. That's it. There are no where conditions and nothing else. So this information gives you an idea of what the engine is doing to answer your query. You start from base table, and the engine will run several queries and then compose them through the formula engine in order to answer the final query. Nevertheless, we have three measures here. We have open orders, amount in USD, and amount in euro. Which is the one that we want to work on? We can simply comment two of them, look at the amount in euro, and that is going to take 1.6 seconds. We can look at amount in USD, so we only check one measure, and that should be pretty fast. You see, it's only 31 milliseconds, so it's much faster, and it's totally useless that we spend time here. And then we have open orders. Let's see how much time it takes to run open orders. If I don't remember bad, this is pretty bad, so it's going to take forever to run. Out of 11 seconds, it's already 9.3 seconds. Yes, you can look at the detail here, but it's very, very clear where the problem is. With that said, optimizing open orders requires a bit more time. So for now, we focus on amount in euro, and we try to optimize that. How can we do that? First of all, we need to look at the code of this measure and then start working on it. We need to understand the content of the measure and optimize it. One way of doing it is open Power BI, go to the order table, click on, amount euro. And from here, you start looking at the code, modify, try something, and then you run it on the other side. But that would be extremely time-consuming, and we don't want to spend our time doing that. Instead, what you can do is search for the measure here, amount in euro. And if you right-click, you have the option of defining the measure. If you define the measure, the DAX Studio will add to the query the definition of a measure with the same name of the measure, which is the model. And the measure is all here. So now you can modify the content of the measure here, and the engine will use this local measure instead of using the global measure, because this measure will hide the original one. This gives you the option of modifying the code, change whatever you want, measure the difference in performance, and only when everything is fine and the code is fast as you want, you copy and paste it in Power BI. You have multiple options here, because you can define the measure. You can define dependent measure, because in reality, orders amount uses amount USD. So this is a measure call. And you might want to see also amount USD. So if you define the dependent measure, then the DAX Studio will also give you the definition of amount USD. So you have a better picture of what is happening in all the measures which are used in the model. You also have the option, let me remove that, of defining and expand the measure. If you only do that on the right measure, which is amount euro, define and expand measure, in this case, DAX Studio will simply run through the code of your query and replace all the measure call with the code of the measure. So you have only one giant expression that contains everything, and you have a better picture of what is happening under the cover. With that said, let's just go for define dependent measures, and we start looking at this code. Amount euro computes, iterates over the orders, and then calls amount USD. Amount USD is just a simple sum. It doesn't do anything complex. So it's nearly impossible to optimize amount USD. We know that we can ignore it, and we can take a deeper look at the code. What is it doing? Let me see if, yeah. Can you read it from the bottom? Say yes or no. OK, fair enough. So what we have here is an iteration over the orders. We compute the amount on USD. And then all this logic basically check if there is a lookup value searches for a row that contains the average. So if I have the average rate in the first month, in the first day of the current month, then give me the average rate of the first day of the month where the currency key is euro. So it's basically searching for the exchange rate on the first day of the month of the sale. Fair enough, it's needed. So once it has the exchange rate, it will this stuff is blank. So if there is no average rate, then it computes the average exchange rate for euro. The thing is, exchange rate, you might not have the exchange rate for all of the possible dates. And if you don't have exchange rate for all the dates, then being forced to do some currency conversion, you multiply it by the average of the exchange rate. Otherwise, if you have a value here, then you go here and you get the average rate. All this if statement basically returns the average rate needed to use it, and amount USD computes the amount of USD. You multiply one by the other, and you obtain, as a result, the exchange rate. I've seen somebody taking pictures. This code is totally awful, so please never use it in your life, because it's designed specifically to be slow. That means once your colleague asks you, can you optimize the report? You look at the code and says, no, I'm sorry. I will never do that. Go learn DAX, and then we come back here. Nevertheless, we are fair, and we want to optimize the code. What can we do here? Well, if you look at that, we have this calculation that computes the average rate, which appears here and appears also there. So we are doing twice a calculation. We can get rid of it. Not get rid, but we can store it in a variable, for example. And let's call it exchange rate equal all this stuff. OK? And then return. We format it. I typically format it a lot of times because I want to make sure that the code is still correct. So here we can simply check if is blank ER, then compute everything, otherwise return the exchange rate. OK? So I compute exchange rate with a variable only once, and then I multiply one by the other. I run it because I am searching for better performance. And it's taking 1.3 seconds. Does anybody remember how it was the time before? Yeah, no, not 11 seconds. That is just a small part. It was something like 1.5, 1 point something. But we are not obtaining any great result here. Besides, while doing all this operation, we forgot that before we had to fight with the Power BI cache. Now we still have to fight with the DAX cache. Also, DAX has its own cache, and it caches data caches generated by storage engine. So if we want to get good measures, we need to first clear the cache and then run the query. So we need to change the way this run button works, and then we run it again. It will send one first query to clear the cache, and then a second query that actually executes the code. Now we have a good baseline because we have removed the cache usage, and we can say, well, with variables already, we are saving we start from 2.6 seconds. OK, that is fine. The remaining part here is not all that bad. There's not much that we can do here. Does anybody see anything totally wrong with this query? Or let me ask it in a different way. How many of you have seen Marco's sessions this morning? Cool. So To all of you, do you see something which Marco said, never do that, it's totally bad. If you do that, no, Marco doesn't use go to hell, but we have some X over orders, and then we return the amount in USD, okay? Amount in USD is a measure, and we are relying on context transition. So we hope that this calculation will happen row by row, and we are calling a measure. Unfortunately, context transition used on the fact table, which is what we are doing here, has two major drawbacks. The first one provides wrong results, and that should be enough for you to stop using it. But if that is not enough, it also makes the engine incredibly slow. Why, and how can you see that? If we run this query, okay, this is only computing the exchange rate. And you will see in the list of the queries that we have one query that retrieves 1.6 million rows. Now, this number, 1.6 million rows, is very, very similar to the number of rows that we have in the order table. It's not very, very similar. It's actually the same value. It's really the same number. The engine is retrieving all of the rows of the fact table, and then it's processing them one by one. This query plan is incredibly slow. So I guess you know what we need to do. I don't remember if Marco told you or not, but the thing is you should never use here a measure to compute the value. You only need to compute from orders the amount, which is the amount in USD. Because if you call a measure row by row, what you want to do is grab the value of that row and compute the number. Make sense? Once you do that, you clear the query, you clear the cache, run the query again, and we move from 2 seconds to much better, 342 milliseconds. So now we are running at a decent speed, 342 milliseconds. It's much better. Nevertheless, it's not still perfect, because what we can do is try to optimize it a bit better. What we are doing here is, from a logical point of view, we are still iterating row by row, and for each row, we are grabbing the exchange rate at the beginning of the month for that date. Okay? But we do that row by row for the sales table. Is it really needed to do that in this way? You can do better than that. At the end, if you have the exchange rate only once a month, there's no point in iterating row by row and compute the value. You can first compute the sales month by month so that you get a few hundreds of rows out of the 1.6 million rows, and then you compute for that few hundred times the exchange rate, avoiding to compute that in a more nested iteration. Make sense? How can we do that? Well, instead of iterating over orders, we first group by. We summarize orders by orders. Not by orders, by date. Year month. We have a column containing the year month. And this is returning the year month of the order. We need to create a new column. Add columns to all this stuff of sales amount, which is calculate sum of sales, sum of orders amount. Okay. If I make any mistake, just tell me before I move further. So I'm iterating over the orders, doing a group by year month, and then I'm computing the sum of orders amount. The thing is, if I start now, this will return 12, 24, 36, 100 rows containing the year month and the amount of sales. But I need, if I do that, I lose the capability of grabbing the order data, because I no longer know the order date. I actually don't need the order date. I only need the first day of the month. So I can take, let's say, the max date, which is, again, calculate max of date. So I have the max data, and then I put another add columns around it. Add columns. Okay, which is the same expression. A data that takes the year of max data, then the month of max data, and then 1. Let's call it exchange date. No. Yes. OK, now I have a first iteration that computes year, month, sales amount, max data. I add to it a date containing the exchange data. And then I can replace all these expression with exchange data. And that's it. I don't need to do anything more complex because I have average rate. And what I need to return is no longer orders amount. Instead, I need to use sales amount, which is, keep in mind, sales amount is the column that I'm computing here. OK? Everything else should be fine. Let's format the code. It is not. I have a parenthesis here that we don't need. OK, now it works. Clear the cache. We run it. Look at the query plan. Now look at the server timing. That's a bit too fast. I guess it ran to an error. Exactly. I knew that would happen. The syntax for date is incorrect. Where is the problem? Define. That closes if var return if is blank calculate. Sorry, speak louder. The max data. Oh, I guess yes. I need quotes here. Let's try that. Did I already tell you that I love you? If not, that might be a good. Thanks. Now you see that by changing the code, we move from 2.6 seconds to 57 milliseconds. So we have been able to change the query, modify the way it runs, and now we have optimized everything. Now we are happy. We can take all of this code, and now we can go back to Power BI. I guess it's worth to note that it's very sad, but all these operations are done outside of Power BI. So now we have amount in euro. We can put it here. We should have checked that the number returned is the correct one. But you know, that's how BI professionals work. If the number looks reasonable, then it's correct unless the user complains. OK, so we optimized the amount in euro. Let's take a look at the slide so I tell you what I forgot to tell you. So we played with currency conversion. And in order to optimize it, we didn't need to do a lot of operations. We basically follow best practices. We just we use variables whenever we could. We avoid iterations over iteration. And we move from 2.6 seconds to a bunch of milliseconds. So the engine is running a bit better. And the idea of DAX is make it simpler. Try to write the simplest code you can, because that will be fast. In looking at all this stuff, you have seen that there are queries which are executed by the engine. Who is this engine, and what are the engines that work in Power BI, not in Power BI, but in analysis services. There are two of them. There is the DAX calculation engine, which we called friendly the formula engine. And then there is the storage engine, which we call friendly VertiPaq. These two engines are two parts of the DAX query engine that answer all of your queries. Storage engine runs the low-level query. The queries that we have seen in XM SQL are executed actually by the storage engine on the column store generated for your model. Once storage engine returns the result of these queries, those results, which are called data caches, are sent to formula engine. Formula engine takes the result of data caches and then work on them in order to produce the final result. So just to give you an idea, but the total sales, the sales amount grouped by year, month that we computed earlier would have been computed by storage engine. And then its result was sent to formula engine that using that will probably do the multiplication for the exchange rate. So the engine is probably, I haven't looked at the detail, but I would expect that it created one table containing sales amount grouped by year, month, another table containing year, month, and exchange rate, and then the final join was done by formula engine. Optimizing DAX basically means working here and only think in terms of formula engine and storage engine. The two have one characteristic that distinguishes them, and it's very simple. Storage engine is fast, formula engine is slow. It's as simple as it is. It's a bit more complex than that, but mainly storage engine runs in parallel. It can run on as many cores as you want, and so it scales very well. Formula engine, on the other hand, is still single core. So if you have a measure that uses a lot of storage engine, you can scale it. You can increase the number of cores, and that will run faster. But if you have a formula that uses a lot of formula engine, no matter what you do, no matter how many cores you have, it will always use one core. So you might buy the beautiful analysis services on Azure and increase the number of cores and increase the power as much as you can, as much as you want. Your formula was slow, and will still be slow, no matter what. So optimizing basically means try to avoid formula engine and try to increase the usage of formula engine as much as you can. I guess I did the opposite of what I wanted. You want to reduce formula engine and increase storage engine. The more work is done by storage engine, the best. Formula engine is slow, storage engine is fast. So you need to use storage engine as much as you can. How can you do that? It's very simple. The simpler DAX you write, the more you can use storage engine, because storage engine, in order to be fast, does not know how to do a lot of calculation. Storage engine can do simple mathematical operations, sum plus minus division and stuff like this. It can follow relationships. It can compute averages, counts. But everything else, starting from a simple if statement, is already too complex for storage engine. So as soon as you start using if, switch, type conversion, all these features will require formula engine. And the two engines communicate through a structure which is called data cache. You start from the column store where all your data is. Storage engine will query it, generate data caches. It will generate many of them because it's running in parallel. Then all these data caches are consolidated into a single data cache, which goes to formula engine. If you remember, the query that returned 1.6 million rows was generating a data cache with 1.6 million rows, so a large data cache, on top of which then formula engine need to iterate and do more work. So because formula engine is single-threaded, the consolidation of data caches need to happen earlier than that. Why did I tell you all this stuff? Because it helps in understanding the couple of optimizations that we are going to run now on the open orders table. Because on the open orders formula, okay? So let's go back to our report. We are happy with what we did on this query. Now it's running in 57 milliseconds. We can get rid of all this code because we already optimized it. Sorry. In reality, we can get rid of everything, go to all queries, double-click on the original query, and we optimize the amount euro. Amount USD does not need any kind of optimization because it's already very, very fast. We restore the query that we want to work on. We format it, and we know this query will take 6-7 seconds, something like it. We need, this is Power BI that uses the table name before the measure. That shouldn't happen. It's using open orders, so we need the definition of open orders. What does it mean for an order to be open? Define the measure and all the dependent measures. The code is pretty simple. It defines two dates, the starting period and end period, which are the minimum and the maximum of the date in the current filter context, and then calculates the number of orders where the order date is less than the end period and the delivery date is greater than the start period. It's harder to speak about the open orders looking at that, but it's much, much simpler if you think at what does it mean for an order to be open. When you have a selection on time, let's say you have 1 month, you have multiple orders. Order 1 was ended before the beginning of October, so it's not open. Order 2 started earlier and is not yet finished. That is open. Order 3, it started earlier, it finished later, so it started in October, but just because it was started in October and not yet finished in October, during October, it's open. Make sense? Then order 4, who cares? It starts later. And order 5, well, order 5 is not open at the end, but during October, we can consider it either open or not open. That depends on discussion to that with the user to understand exactly what do you want to consider as open or not. What we do is a simple calculation. We check that the order date is before the end period, so it started before the end, and it ended after the start. Okay? If both conditions are true, then the order is considered to be open. And this measure basically does a calculate count rows of filter orders for all data. Okay? Now, let's clear the cache and run it. It's still running. I don't remember how much time it was, something like 7-8 seconds. That should run. No, more than that, 10 seconds. 10.6 seconds. So this is the code, and these are the numbers we gathered. To run the query took 10 seconds. Now you should start to have a feeling about the difference between storage engine and formula engine. Storage engine CPU tells you how much CPU was used by storage engine. Formula engine was the time used by formula engine. Storage engine is using 4.8% of the total execution time, formula engine 95%. This is a query that uses a lot of formula engine. And you can easily check it even without having DAX Studio, because if you simply open the task manager, okay, right now you see the PC is basically sleeping. We run the query. And if you look at the diagram here, you don't see a spike. The CPU are not being used. Your PC is just there with one core, formula engine, running and trying to answer the query. So it doesn't matter how many cores you give to this PC, it will never use them with this kind of query. What can you do in order to make this code run faster? Do you see anything wrong here? That I don't know if Marco told you that or not, so I'm just guessing. Sorry? Yeah, the thing is, you need to remember that Tabular is a columnar database. A columnar database shines if you work on one column only. And it slows down and slows down and slows down the more column you use in your expression. Why do you want to filter the orders? This is a scan of the fact table, and check 2 columns at a time. To do that, the engine, as you see here, will need to ask to storage engine to materialize a data cache, and this data cache contains the raw number, the sales order date, and the sales delivery date. So it's basically materializing the full fact table, not all the fact table, but the columns which are needed in order to answer the query. And of course, this takes some time. And once the table is materialized, then Formula Engine will do all the rest of the job. You can make it much, much faster by simply changing the way the code looks like. We already have the start period and the end period as variables, so we can take these two conditions and simply separate them using calculate. And that is just count rows of orders. OK. I guess I need to remove that too. No, I need to remove a comma too. Ah, now it works. Now, by simply changing and separating the condition order date less than end period and delivery date greater than start period and removing the filter on the date for sure, if we run the query, now this is way, way better. Runs in 77 milliseconds. Out of these 77 milliseconds, 47 are storage engine, 37 are storage engine, and the total execution time is 41 milliseconds of Formula Engine, 36 of storage engine. Okay? So just by changing slightly the code, you can obtain much, much better performance. Now we have it, and we can go in Power BI and replace it. Where is it? Open orders. If we are lucky, now the report should be much, much faster. You see that we can move, and this is what you would expect from a report that runs on 1.6 million rows. Yet, one of the problems that you might face is that you should not really be completely satisfied by this query. Because this query that does a calculate count rows of orders and then applies the to filter still applies filtering conditions. And what the engine does in order to completely answer the query is take the individual columns and take still the table year, month, that is coming from the date. You see, it's taking the delivery date from sales, and then it has these conditions which are injected by the engine, which might be more complex. So this query is still using a lot of Formula Engine. 53% is Formula Engine, and the storage engine is not doing a lot of work. When you have a query that is still very Formula Engine bound, you typically see a behavior which is a storage engine generating large data sets, and then Formula Engine iterating on top of them. And the time needed to answer those queries depends on how complex your query, how complex your report is. If you build a report that contains, for example, country region and then the year and our open orders measures, this is going to be fast if you only browse it this way. But if you start expanding and then expanding at the day level, it takes a while to compute those values. It's not extremely slow. Still, it takes a while because Formula Engine need to compute values. If you really want to obtain the best performances out of a model like this one, what you need to do is slightly different and a bit more complex. So what you need to do is, well, if I have a data model like this one, there's not much that I can do because the code is what it is, and this is what you need to compute. But you can change the data model. Changing the data model is 90% of the time your best friend in order to optimize a model. If instead of having data at the order granularity, you move data at the day granularity, you can generate a table that instead of having one row per month or one row per order contains one row per order and date, and basically tells you if that order in that day was an open order or not. Make sense? If you have such a table, then you no longer need to do complex math. How many orders are open in a given period? You do a distinct count, and that's it. You don't need anything more complex than that. But we don't have the table. So one option is that of going back to SQL or ask the SQL guy. Ask the SQL guy is typically what to tell to Power BI users. Here we are all SQL guys. But you need to work on SQL to build the model. Here we have a better option, which is that of creating a table straight in SQL, straight in DAX. So what we can do is first generate such a table. What we want is a table. No, we need to use generate. For each orders, we want the dates between date, the dates between the orders order date and the order's delivery date. Okay? If I miss a parenthesis, okay? This is basically iterating order by order, and then for each order, it computes the set of dates between the order date and the delivery date. Okay? During this row, this table will contain all the data of orders plus a new column of date. We don't want all of the columns, so out of this, what we want to get is only the order key, which is order key. I hope it's named order key, and it's very stupid that I write it when I have it here. Oh, we have the order number, okay? We want the order number, we want the date, which is just the date, and now we avoid the problem from the beginning using quotes. And that's it, we don't need anything else. This table will return for each order the dates. And that's going to take a while because it needs to return 1.6 million rows. So we can simply take this code and just pass it in the model here by creating a new, by going to modeling and build a new table here. Let me. Have we been able to crash everything? No, not yet. Okay, let's call it open orders. So we see the result. That shouldn't take a lot of time to execute it. By the way, since we are going to finish exactly on time, if you have any question, it's better that you use this spare time while we wait for the PC to finish. Otherwise, we can stop it here. Yep?
Alberto, let's say that I have a chain of dependent measures. So I've encapsulated some business logic, and I have measure 4 that references measure 3, that references measure 2, et cetera. Should I expect any performance impairment by doing that as opposed to repeating the logic of any of those dependent measures?
So the question is it better to use, to call measures or to embed the code of a measure in the only measure you are writing? The answer is there are no differences at all. Yeah, in reality, there is a small difference. Let's say, from a logical point of view, what the engine does to answer a query is the full expression tree where all the measures are expanded. So it's as the measure were not there. So you can reuse a measure as many times as you want with no problem at all. With that said, there is part of the algorithm of the optimizer, the one that searches for subtrees of the expression tree which are identical to avoid the multiple calculation of the same object, that uses the measure name as a helper to find identical paths. So sometimes it's better to use the same measure multiple times than to expand the code in your measure, because you are helping the engine that optimizes the subtree, I don't remember, the identical subtree scansion of the expression tree that reduces the number of execution. So using measure is absolutely fine. Now we have the open orders table. We can only need to build the relationship between open orders and data. And now that we have this table, this basically contains an order only when that order is open and the data. It has a relationship with data, so how can I compute the number of open orders? It's just a distinct count of the order key. So the code is much, much simpler to write. But I think I'm so smart that I removed the query that I wanted. But it's worth to know that when undo is done the right way, it has a lot of sense. Microsoft still doesn't understand this, but one day, maybe. Distinct count of open orders order. Okay. Okay. Oh, I lost the connection. That was the problem. And I no longer can connect, so I need to close and open DAX Studio. DAX Studio is not perfect, of course. It's built as open source, but it's still much better than whatever you might have. So I need open orders without the space.
You should talk to the developer.
Developer of who? Of what, sorry? Because I might talk with the Microsoft developers asking for them to build such a stuff and not forcing other developers to lose their time to do that. Or I can talk with the guys that develop this beautiful tool in their spare time to make our life easier. And I guess you know to who.
Which we are great.
Yeah, but I'd rather prefer talk with Microsoft. Say, come on, guys. We need the server timings. Does anybody remember what was the time execution time earlier? Order key. Okay. This is not going to be much faster. So if we look at the total execution time, it's now 300 milliseconds. Not only it's not faster, it's actually a bit slower than earlier. The difference between the two is basically that this uses only storage engine. You see that storage engine is doing everything, and formula engine is doing a tiny part of the execution time. So on this PC with 1.6 million rows, this measure is actually slower than the one that uses more formula engine. But if in a larger model, instead of having 1.6 million rows, you have already just 100 million rows or 1 billion rows, then the difference between the two will be huge, and the one using storage engine will be much, much faster because it will scale on multiple cores instead of running on a single one. Yes? In the open orders table. Sorry, the question was how many rows we have in the open orders table or in the orders table. The open orders is actually larger than the orders table, of course, because it contains multiple rows. And it's 10 times. Now it's 16 million rows. Of course, the size of the open orders table depends on the duration of an order. So if you have an order that lasts for a few days, it makes total sense to use this technique. If, on the other hand, your orders last for 5 years, then this technique is absolutely the wrong one because the table will generate will be huge. But to be honest, if an order lasts for 5 years, then already the idea of having the open orders by date doesn't make any sense. You will probably move to the month granularity, and there you start to reason and do the math. That's why when I see 1.7 trillion rows, I'm not against those kind of demos. They are very cool to look at. But if anybody tell me, oh, I have 2 trillion rows to analyze, I would say, hey, maybe we might work on the data model and reduce granularity and go to a human site. If you just throw data in the data lake and hope to query that, that is not likely to be your best option. OK. So by changing the model, we can create code that runs in different, that uses more storage engine and less formula engine. Unfortunately, we have only 75 minutes, so there is no way to cover all the details that would be beautiful to look at. What I wanted to share was more just a real experience and see what you might do in order to optimize your code. If you need to do any kind of optimization, first of all, download and install DAX Studio, because that's the best tool that you can use. And today is the only tool. You don't need anything else. Just install that, and you're happy. And think that optimizing is a complex process. First of all, you need to learn and understand what to test for. Then you need to search for the performance problem. And then you work on that slowly by changing the code. Remember, sessions evaluations are important. If you want to see other sessions like those, the guys use session evaluation. And we use them, by the way, to understand what was wrong and what was correct and what did you like about the session. So please go there, evaluate your session. You are helping me, and you are helping all the teams that organize Pass Summit. With that said, thanks a lot for attending the session, and I hope you liked it.